Yeah, good morning to all of you. In this lecture, I will discuss about the concept of classical mechanics, or detailed discussion about the classical mechanics that will cover the all competitive examinations like NET, GATE, TIFR, and any Central University PhD entrance test, or CUET PG test. So classical mechanics. So before starting the details of the syllabus, I will just talk about the concept of what is mechanics and its classifications. So the first question is, what is mechanics? So mechanics and its classifications. So mechanics is just a study about motion of physical objects or motion of any objects under the influence of forces, internal or external forces. So study about motion of under the influence of forces. So this is very simple definition and its classifications. So on the basis of their property, mechanics categorized into are classified as, the first one is, so we can write it as classification of mechanics. Of mechanics. So the first one is Newtonian mechanics. Second is classical mechanics. Third, we have another mechanics, that is relativistic mechanics. Next we have statistical mechanics. And last one is quantum mechanics. So this is the simple classification of mechanics. Mechanics is simply study about motion of physical objects under the influence of internal or external forces or interactions. The first one is a Newtonian mechanics. So I will just discuss about the brief intro about all these mechanics. So what is Newtonian mechanics? So Newtonian mechanics is which is based on the Newton's law of motion, or this is vectorial mechanics. So we can say, write it as, this is vector mechanics. This is vector mechanics which is based on Newton's law of motion. In this mechanics we will study about the vector quantity, vector entity, that is force, momentum, velocity, acceleration. So this is vector mechanics, and this mechanics is based on Newton's law of motion. The first law, there are three laws. The first one is law of inertia, second one law of force, that is rate of change of momentum is equal to applied force. Third one is law of action and reactions. So similarly we have another, there are some failure of this mechanics. So in order to adequate, or in order to overcome the inadequacy of this Newtonian mechanics, new mechanics has been developed, that is known as classical mechanics. So classical mechanics and is basically this is analytical mechanics. This is analytical mechanics, or we can say that this is a scalar mechanics. This is scalar mechanics. In Newtonian mechanics, our physical quantity is simply force, velocity, momentum, and this is our classical mechanics is simply based on. So this is a analytical mechanics. Analytical mechanics, the physical quantity that we will discuss means we will study each and everything in terms of energy, which is scalar quantity. We will discuss each and everything in terms of energy, which is scalar quantity. In Newtonian mechanics, our physical quantity is force, velocity, momentum, which is vector. Sometimes it is very difficult to handle the vector entities. That is why this mechanics is developed. And who developed this mechanics? The major contribution in developing or in order to develop this mechanics is D'Alembert, Lagrange, and Hamilton. In another word, we can also say that they will develop a new type of tool to analyze the behavior of mechanics, in terms of scalar entity instead of vector entity, because it is very difficult to handle sometimes it is very difficult to handle the vector quantities. Means we need to take care of both magnitude and direction. But in this is analytical mechanics, so this is a scalar mechanics, so we need to only take care of, and it is very easy to handle the scalar entity. So that is why this classical mechanics has been developed, and it is developed by D'Alembert, Lagrange, and Hamilton. They developed a tool basically to analyze the and what is our objective? What is our overall objective of the mechanics? This is the very important question, that what is our objective in mechanics. So in one word we can say that to study the trajectory of particles. And what does mean it? Trajectory of particle means path followed by the particles. So how to analyze mathematically in order to understand the mechanics? So in Newtonian mechanics we have very good tool, that is F equal to ma, which is rate of change of momentum equal to applied force, and F equal to ma is basically, this is a F equal to mass times d2x by dt square. So F equal to m into d2x by dt square. So this is basically in Newtonian mechanics we have F equal to ma, so mass times d2x by dt square, which and this is second order differential equation. So in order to find out the trajectory of any system, any single particle or a system of particles, we have to solve this equation, and the solution of this differential equation will tell us the trajectory of particle. If you will solve, we will get some xt. Suppose for example, if you are solving a simple pendulum problem or a spring mass system, which is simply a second order differential equation, and if we will solve this second order differential equation, we will have some solution in terms of xt equal to a sin omega t or xt equal to a sin omega t plus phi. So and what is this xt? This xt is simply the displacement equations, and this displacement equation will tell us and this is the trajectory of particle. So that is why in one word we can say that what is our overall objective in this mechanics is to analyze the trajectory of particle, or to study the trajectory of particle. And how to study the trajectory of particle? By solving the, how to study the trajectory of particle mathematically? By solving the differential equation, by solving the second order differential equation, which tells us the displacement equation, which gives us the xt, which if you will solve this d2x by dt square, so the final solution is in terms of xt equal to some a sin omega t plus theta, or some a cos omega t plus theta. And what is this xt? What is this xt? This xt is the instantaneous position of particle. This xt is basically instantaneous position of particle, which means what is we can, if you know the trajectory of particle, in another word we can say that if you know the trajectory of particle, you can predict, or you can tell each and everything about the system. You can tell each and everything about the particles or system of particles. So what is the instantaneous position? This xt means what is the instantaneous position of your particle at t equal to 0 and at any later time t. And once we have the profile of this xt, which is the instantaneous position, we can find out the, it means if we have the profile of instantaneous position, so we can easily find out the velocity, we can easily find out the momentum, we can easily find out the acceleration, we can easily find out the force. So this is the overall objective of the mechanics. And in Newtonian mechanics we can easily find out all these parameters, and this is the means if we have a xt, we can find out velocity, position, momentum. So similarly, but there are certain restrictions in this mechanics that because this is a vector mechanics, so that is why a new mechanics has been developed, that is known as classical mechanics, which is analytical mechanics, or in other word which is scalar mechanics. And who develops? D'Alembert and Lagrange and Hamilton. They developed the analytical way to find out the trajectory of particle by analytical approach, by scalar mechanics, by scalar entity instead of vector entity. Now in some situation, if our particle have very high velocity, up to the order of c, so to analyze the behavior of particle, we need to develop another mechanics that is known as relativistic mechanics. We need to develop another mechanics that is known as relativistic mechanics, because in this mechanics what we know, rate of change of momentum. What is Newton's law? Rate of change of momentum is equal to applied force. And what is P? This d by dt of P is simply mass times velocity, P equal to mv. So in earlier case, this is simply m into dv by dt, which is mass times acceleration. But in relativistic mechanics, mass is velocity dependent. So in this case, we have this profile m dv by dt plus v dm by dt. So and in earlier case, we have simply, in Newtonian mechanics, what is our f? F is simply mass times dv by dt. But in this case, so this is the mathematical explanation there of relativistic mechanics. Means if the particle velocity is very very high, up to the order of c, then we need to develop another mechanics, because we cannot deal, because Newton's law failed. At this speed, our Newton's law fails. So what we have to do, we have to develop another mechanics that is known as relativistic mechanics. In this mechanics, our rate of change of Newton's law is simply d by dt of mv, and we will differentiating it by parts. In Newtonian mechanics, mass is a constant, so we can take it outside, and f is simply m into dv by dt, which is mass times acceleration. But in this case, we have m dv by dt plus one more additional term, which is v dm by dt. See. So next we have a statistical mechanics. I will just give you the little bit flavor instead of detailed explanation. I will just give you the little bit flavor about all mechanics, that what is statistical mechanics. See, in what we have, In Newtonian mechanics, if we have a single particle or a system of particle, we can write down, we will simply write down the equation of motion to analyze the trajectory of particle. If we have a one particle, two particle, then it is very easy to write down the equation of motion to analyze the behavior of system. But suppose we have a very large number of particles. If we have a particles, if we have 1,000 particles, if we have a 10,000 particle, if we have a particles of the order of the 10 to the power 23 or 10 to the power 20, then it is very difficult to write the equation of motion corresponding to each particle in order to analyze the behavior. Then what we will do, we need to develop another mechanics to analyze the statistical, to analyze the average behavior of particles. Suppose we have a average behavior, suppose we have a particles inside the container. If we have 1,000 particles, so it is very difficult to write the equation of motion corresponding to 1,000 particle. Means we have to write 1,000 times equation of motion in order to analyze the behavior of that. That is why we need to develop another mechanics. We need to develop another mechanics, that is statistical mechanics, which tells us the statistical behavior, which tells us the average behavior of the system. So for example, molecules in a container. So molecules in a container. So in statistical behavior, we have another very three important keywords. How to analyze these statistical behavior by ensembles, by the concepts of ensemble, and we have three, that is ensembles, and we have three important ensembles, that is microcanonical, canonical, and grand canonical ensembles. So it's all about the statistical mechanics. Now if we have a particle size is very small, in this case particle's velocity is very high. If the particle size is very small, up to the order of atomic dimension, means up to the angstrom order, if we have a particle whose size is of the order of angstrom, then it is very difficult to analyze or apply all these mechanics. Then we need to develop another mechanics. So in another word, we can say that to analyze the microscopic behavior of system in which particle size is in atomic dimension, so we need to develop another mechanics, and that mechanics is known as quantum mechanics. So if the particle is very small, of the order of angstrom or in atomic dimension, then in that case we need to develop, or to analyze the behavior for corresponding this situation, we need to develop another mechanics, that is known as quantum mechanics. We have another mechanics, relativistic quantum mechanics. Relativistic quantum mechanics. It means if the particle size is very small and whose speed is very high, up to the order of c, or velocity of light up to the order of 3 into 10 to the power 8 meter per second. So in that case we have to develop another mechanics. That mechanics is known as relativistic quantum mechanics. Means particle in microscopic dimension and whose velocity particle are very small, up to the order of angstrom order, and whose size whose velocity is comparable to the velocity of light. In that case we need to develop another mechanics, that is known as relativistic quantum mechanics. So in relativistic quantum mechanics, so I think it's all about the brief introduction of the mechanics. So mechanics is simply study about motion of physical object under the influence of forces, and what is our overall objective in this mechanics? To analyze the trajectory of particle, or system of particles. So depending upon different situation, we have different types of mechanics: Newtonian mechanics, classical mechanics, relativistic mechanics, statistical mechanics. Means particles are, if the particles are very large in number, so we cannot write the equation of motion individually in order to analyze the individual. So that is why we will study the statistical behavior, average behavior of particle, so by concept of ensembles, and we have three different types of ensembles: canonical, microcanonical, and grand canonical. And if the particle size is very small, up to the order of angstrom, then these mechanics, then we need to develop another mechanics that is known as quantum mechanics. So quantum mechanics is the explanation of everything. Next we have relativistic quantum mechanics, if the particle size is very small and whose velocity is comparable to the light. So in that domain, that is known as relativistic quantum mechanics. So I think it's all about the basic and brief introduction of mechanics. Thank you.